Hi, everyone. This is a presentation for project Emotion-Based Synthetic Feature Binary Classification of Human versus LLM-Generated Text and Essay. So emotion analysis is a popular method to classify text into various emotions through scanning text in search of keywords to definite emotions. LLMs has become more capable with potential to cause harm through information fabrication. So in this project, we not only ran through multi-classification for different emotions, but also perform binary classification between human and LLMs to see any patterns we could be concluded. Our short-term research goals are to develop a multifunctional model that could categorize unstructured raw data into 7 sentiments through the NLP with over 90% accuracy, and could also differentiate origins from human versus LLM. Our long-term industry goals are to authenticate product reviews, detect academic plagiarism, and upgrade LLM medical system performance by adding more human-like tones and emotions. Our competition dataset comprises about 57,000 essays, and 70% were written by students, and 30% were generated by various LLMs. We arbitrarily set 0 as human-generated and 1 as LLM generated in our experiment. So our system 1 is emotion multi-class classification. So DistilRoBERTa is a transformer whose weights have been trained at main tasks. Thus, its skills are simply transferred to the emotion classification task. Transformers use encoder and decoder architecture with context to make predictions. Our system 2 is a binary classification. The SPACY NLP pipeline is responsible for tokenization and cleaning the text data before it's processed, eliminating anomalies and letting the model focus on only the important parts of the text. The backend words is responsible for building the numerical version of the clean text so that the model can interpret the text. The logistic regression is responsible for classifying the text using the newly created emotion feature and the existing vector representation of each essay. The more the feature, the better the results, but also the slower the model. So the next are our hyperparameter setup for our pre-trained transformer, Hugging Face, logistic regression, and all these hardwares. For the evaluation metrics, we comprehensively adopt accuracy, precision, recall, and general running time. So here is a sample text implementation. As you can see here, a sample paragraph running through the DistilRoBERTa transformer to get emotion labels and emotion scores. And then the dataset is going through the neural network to complete binary classification of human versus LLM, as well as the evaluation metrics. So as you can see here, the label is as 0, and we have all the accuracy, precision, recall as over 97%. So the results of emotion multi-class classification shows that there are potential patterns and traits between texts from human and LLMs. That is, firstly, LLM tends to generate more joy than human. Joy is the only category where LLM exceeds human. Secondly, LLM is more likely to generate positive messages instead of its negative and neutral counterparts. Thirdly, humans generally display more types of emotions in written text and essays. So these are the results for our binary classification of system 2. As you can see here, the LR with emotions performed the best so far in combination of the accuracy and the time efficiency. Although SVM's accuracy might be slightly better than the LR, but it down perform a little bit in the training time. And the reason for the LR performed the best so far is that it's a simple classifier that make running time faster, and the more features give the model more data to work with, making it more accurate in its prediction. So at this point, we can conclude that adding features to classification task helps improve the model. For text classification, adding feature is a very, very hard task. And use of pre-trained transformer model helps achieve at least 26% higher binary classification accuracy. And lastly, this overall experiment proves that using a system of pre-trained transformer to generate synthetic text-derived features helps improve the binary classification of human versus LM generated essays. All right, so these are all our contact information. If you have any thoughts, ideas, please do not hesitate to reach out. And thank you very much for everyone's time. I hope you enjoy the presentation. Thank you. Bye-bye.